Hello there and welcome back to the Sleep Science. You're standing on the crust of a planet that, frankly, hasn't sat still for even a single moment since it was born. The ground beneath your feet looks solid, dependable, maybe even eternal, but it's actually a cracked eggshell floating on molten rock, a slow-motion chaos. You probably won't survive long enough to see what it's planning next, but the Earth is already sketching out its next great rearrangement. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, tell me in the comments where you're watching from and what time it is right now in your corner of the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You breathe out, and for a moment you swear you can hear a low groan in the distance. It's not your house settling, it's the planet. Down below, where sunlight never reaches, Earth's outer layer is cracked into enormous slabs called plates. They bump, grind and slide against one another in an endless ballet of friction and fury. At their edges they tangle like tectonic lovers who never quite get along. It's strange to think this surface you call solid ground is really more like the skin on hot soup, thin, wrinkled, constantly shifting. The heat from Earth's core keeps everything underneath moving, churning, pushing. The planet is restless because it's still cooling from its birth more than 4 billion years ago. Somewhere deep below, you can almost imagine a fiery heart beating once every few thousand years, keeping time for earthquakes and mountain ranges. Walk outside at night and imagine you can feel the movement, an invisible conveyor belt underfoot. The plates shift at about the speed your fingernails grow, yet given enough time, they can tear open oceans and swallow continents whole. Historians still argue whether early civilizations noticed any of this movement, or if the trembling Earth simply felt like the gods throwing tantrums. The Greeks certainly thought so. Poseidon, after all, was the earth shaker. Modern science gives that old god a new name, plate tectonics. The theory came together only about 70 years ago, which in geological time is less than a blink. Before that, most scientists scoffed at the idea that continents could move. They pictured Earth as a stable globe, the continents fixed like paint on a ball. It took Alfred Wegener, a German meteorologist with the audacity to connect the dots, to notice that South America and Africa fit together like puzzle pieces. His colleagues laughed him out of the room, but sometimes being laughed at is just the sound of the future arriving early. Decades later, when submarine mapping and paleomagnetic data came in, Wegener's wild idea turned into the cornerstone of modern geology. The crust wasn't fixed. It was a restless mosaic. The continents drifted because the mantle beneath them convected slowly but surely, like thick stew on a simmer. You lean closer to that idea, imagining yourself hovering miles above the globe. The continents don't stay where you think they do. They creep north, south, and sideways. Africa edges east, the Americas drift west, and somewhere beneath the Pacific, a vast plate slides toward its doom in a subduction zone. If you could speed up time, you'd see Earth's surface ripple and breathe like a living thing. One quirky bit of geological trivia: the crust under the oceans is much younger than the crust beneath your feet if you're standing on land. The seafloor constantly renews itself, while the continents carry rock that remembers billions of years. So in a way, the continents are Earth's grandparents, while the ocean floors are perpetually newborn. Listen closely, and you might sense the quiet heartbeat of plate motion, a frequency far below hearing, like tectonic ASMR. It's steady, hypnotic, and vaguely menacing. You stand on a planet that's constantly rehearsing the next act of its geologic opera, and we humans just happen to be the extras walking across the stage between scene changes. There's comfort in that, oddly enough. The same tectonic chaos that shakes cities also builds mountains, renews soil, and stabilizes climate over eons. Without it, Earth would be a barren, waterless rock like Mars. You exist because the crust couldn't stay still. Still, it's unsettling to imagine that your living room sits atop a moving slab of stone tens of kilometers thick, gliding over molten rock that could swallow it in time. But that's the paradox of our homeworld. It's both fragile and unstoppable. The continents will keep sliding long after our species is gone, after the last lights fade from the last city. Somewhere in the dark, another continent will crash into another, and new mountains will rise where your ocean once was. And under it all, the planet will whisper, "I'm not done yet." You hover above that whisper now, tracing the jagged seams where the Earth's shell splits apart. From up here, the continents look like puzzle pieces that someone forgot to glue down. But they're not lying still, they're adrift, floating on a fiery sea of molten rock called the mantle. The crust, your home turf, is only a thin rind on a churning ball of magma, and those pieces, those plates, are constantly nudging and drifting like giant cranky rafts bumping into each other. If you could shrink yourself down and slip beneath your shoes, you'd find a layer called the lithosphere. Cold, brittle, the part that breaks. Beneath it lies the asthenosphere, warm, plastic and sluggish, almost like thick honey. That's where the motion happens. It's the reason Africa inches northeast and the Pacific plate slowly disappears under Japan. The lithosphere floats because it's lighter than what's below it, just as icebergs bob on the ocean. It's a graceful, violent balance of buoyancy and gravity, forever shifting but somehow stable enough for life to evolve and cities to stand. You can almost picture the plates drifting in slow waltz time, though they're not exactly graceful partners. Some move toward each other, crumpling mountains into existence. Others drift apart, letting magma well up between them to form new crust. The edges where they meet, those jagged lines running across the globe, are the world's fault zones, and they're anything but faults in design. They're release valves, pressure points, the reason our planet breathes. Here's a fun historical twist. It wasn't until the mid-20th century that scientists finally accepted the idea of floating continents. Before that, they assumed the crust was fixed, like plaster on a sphere. Even after Wegener's early ideas, many geologists argue that continents couldn't possibly move because the rock beneath them was too strong. Ironically, it took Cold War submarine missions to map the ocean floor and discover symmetrical ridges of newly formed rock to convince them otherwise. Spy tech helped prove plate tectonics. Meanwhile, the quirky side of geology always finds a way to surprise. There's a tiny microplate under the Indian Ocean, barely the size of France, that spins independently, rotating a few millimeters each year, is like a tectonic fidget spinner. Scientists still debate whether these microplates are leftover fragments of older continents or fresh splinters of the seafloor breaking free. Either way, Earth refuses to fit neatly into our diagrams. You imagine the scene inside the mantle, superheated rock flowing upward in slow, looping currents. Hot material rises, cools and sinks again, like water boiling in a pot. That's convection, the invisible hand steering the continents. Over millions of years, these convective cells rearrange the entire face of the planet. What looks fixed on your map is actually mid-migration. Historians still argue whether ancient cultures ever guessed at this grand drift. The Polynesians, for instance, navigated vast oceans using stars and waves, yet they also told stories of islands that move. Coincidence, or some intuitive sense of the planet's hidden motion? We'll never know for sure, but you can almost hear the echo of those myths when a modern GPS satellite measures continental creep down to a fraction of a millimeter. You run your hand across a rock, feeling the roughness of time itself. That stone might have once been part of another continent altogether. Maybe it sat under an ancient sea. Maybe it cooled in the shadow of a volcano that no longer exists. The continents don't just move, they recycle. They trade pieces, they stretch and fold, they drown and re-emerge. What's beneath your feet is a traveller's scrapbook, a record of billions of years of planetary wandering. There's something humbling in that thought. Humans have been drawing borders for a few thousand years, arguing over who owns which piece of land, while the planet quietly shifts the very foundation under those lines. Your map isn't permanent. It's just a momentary pause in Earth's long-term dance routine, and that dance is slow but relentless. The Atlantic Ocean, for example, widens by about an inch every year. That might not sound like much, but over 100 million years, it's enough to double its width. The same process once tore apart the supercontinent Pangaea, and it will eventually close the Pacific. Imagine the patience of a planet that can stretch and tear its own skin over eons, yet still cradle forests, cities, and dreams on top of it. Somewhere deep inside, you sense that faint, unstoppable glide. It's quiet but constant, a global hum of creation and destruction happening right beneath your bed. The crust may be cracked, but it's resilient in its impermanence. The Earth doesn't fear falling apart. It depends on it. You smile at the absurdity of it all. The ground you trust most is the one thing that never stops moving. You're living on the world's slowest roller coaster, and there's no getting off. But don't worry, you've got a few 100 million years before the next big rearrangement, plenty of time for one more nap. You keep that slow-motion rollercoaster image in your mind as the world beneath you tilts and groans, sliding toward its next collision. The continents, after all, are wanderers with no permanent address. They travel, drift, meet, and part again like slow-dancing continents at a party that's been going on for billions of years. And when they do collide, oh, the drama. You picture it now. Two massive plates inching closer over millions of years, like lovers with terrible communication skills. They move only a few centimeters a year, but in geological time, that's practically sprinting. When they finally meet, one can't simply say, "Excuse me," and slide politely aside. One dives beneath the other, sinking into the mantle in a process called subduction, and the upper plate folds and crumples like paper pressed between gears. Mountains rise, volcanoes ignite, and oceans vanish. That's how the Himalayas came to be, the result of India crashing headlong into Asia about 50 million years ago. The force of that collision is still ongoing. Right now, as you listen, the Himalayas are rising about half an inch a year. Somewhere between the peaks of Everest and K2, the Earth is still groaning from an argument that started before humans even existed. But collisions don't just build, they destroy. As one plate sinks, parts of it melt, forming magma that rises to the surface. That's why volcanic arcs form along collision zones. Japan, the Andes, Indonesia, all born from tectonic feuds. Every fiery eruption is a love letter written in lava from one plate to another. You might be tempted to think of Pangaea, the last great supercontinent, as the ultimate example of this colliding world, a time when all the land masses were locked together in a single, massive continent surrounded by an endless ocean called Panthalassa. It formed around 335 million years ago and began breaking apart about 175 million years ago. To Earth, that's not ancient history. That's just last season's layout. Historians still argue whether Pangaea's breakup happened gradually or in a geologic fit of rage, massive mantle plumes erupting through its centre, splitting it apart like overbaked bread. What's certain is that those rifts birthed new oceans, new climates, and eventually new ecosystems. The rearrangement of continents didn't just reshape the land, it rewired evolution itself. When continents separate, species diverge. When they collide again, the world reshuffles its biological deck, and there's something almost comically stubborn about these continents. Take Africa, it's currently stretching itself apart along the East African Rift, where a future ocean may someday form. Imagine standing in the Great Rift Valley and realizing that in 50 million years, the land beneath your shoes could be a coastline. Not that you'll be around to see it, but hey, your descendants' might get a nice beach view. Here's a quirky fact to amuse your sleepy brain. When Pangaea existed, the interior of the continent was so far from the sea that it became an immense desert. No ocean breezes, no humidity, just endless red sand and scorching heat. You could have walked for months and never smelled salt air. Dinosaurs trudged across it, unaware that one day their fossilized footprints would end up scattered across different continents, thanks to the same tectonic forces that buried them. That's the strange poetry of tectonics. It builds and erases in the same motion. Mountains rise where oceans fall, fossils drift across hemispheres, and every rock tells a story of being somewhere else. The cliffs you hike today might have once been the floor of an ancient sea. The granite beneath your house might have formed miles underground before being thrust into daylight. Nothing in geology stays still long enough to call itself permanent. Scientists have a term for this grand pattern of gathering and splitting, the supercontinent cycle. About every 400 to 600 million years, Earth's land masses come together into one giant continent, then slowly drift apart again. It's like a deep planetary breath. Inhale, exhale. The last exhale gave us the world we know. The next inhale will bring a future supercontinent, perhaps Amasia or Pangaea Proxima, depending on which geologist you ask. And somewhere in all of this tectonic theatre, you feel a pulse of time so vast it almost makes you dizzy. The human species has existed for barely a blink in comparison. The ground we claim, the borders we draw, they're graffiti on a moving train. Still, you can't help but marvel. When continents collide, they give rise to mountains that pierce the sky, to mineral veins rich with life's building blocks, to landscapes that shape civilizations. The Alps sculpted Europe's culture, the Andes guard South America like a sleeping dragon. Even now, the collision zones of the Pacific Ring of Fire create fertile soil and fertile fear in equal measure. It's not just destruction, it's renewal. The Earth is constantly resculpting itself, trading chaos for creation. And maybe, if you squint at the horizon and let your imagination drift, you can almost see the next collision coming. The Atlantic closing, the Pacific disappearing, a new supercontinent forming where we once sailed and fought and built cities, and beneath it all, the same patient rumble continues. The Earth's long conversation with itself, told through stone. You sink lower now below the crust, down into the incandescent glow where continents are born and buried. The deep underworld of molten rock, where the real power behind tectonics hums. Down here, the air would shimmer with impossible heat, hotter than the surface of the sun in places, and everything moves in a slow, syrupy ballet. These are the rivers of fire below, the magma plumes and convection currents that drive every mountain, earthquake, and ocean trench above your quiet human life. You hover above that roiling mantle, and you can almost feel the tug of the currents, the swirl of molten rock looping in vast circles hundreds of kilometers wide. It's mesmerizing, like watching thick honey churn, except this honey can melt iron. Heat rises from the planet's core where radioactive decay keeps the inner furnace burning, and as that energy moves upward, it drags the upper layers with it. That's the heartbeat of the planet, the source of tectonic motion. It's strange to think that the same principle you see when soup simmers on a stove is what's pushing entire continents around. The mantle convects in slow motion, spreading heat unevenly, sometimes focusing it into narrow upwellings called mantle plumes. You might have heard of one, the one under Hawaii, tirelessly punching through the Pacific plate to create a string of volcanic islands like beads on a glowing necklace. The plate moves, the plume doesn't. The result? A trail of islands stretching across the ocean, each one a frozen footprint of fire. Scientists still argue whether these plumes are fixed structures that pierce the crust, or if they drift like everything else, bending and wandering through the mantle currents. The debate gets surprisingly heated, pun entirely intended. What everyone agrees on, though, is that without this subterranean motion, the Earth would be geologically dead. No volcanoes, no mountain ranges, no renewal of the crust. Just a cold, silent planet wearing the same surface forever. Down here, deep beneath your feet, pressure builds like a sigh that never ends. You imagine magma rising through cracks, finding its way upward with the patience of eternity. Sometimes, it pauses in the vast underground chambers called magma reservoirs. They sit for centuries, maybe millennia, until the crust above them shifts. Then they erupt in a glorious tantrum of light and sound. And when they do, they don't just release lava. They reshape the air, the oceans, the climate. When Mount Tambora erupted in 1815, the dust and sulfur it sent into the sky dimmed sunlight around the world. The next year became known as the year without a summer. Crops failed. Snow fell in June in New England. Poets wrote of twilight skies that looked like bruises. The planet had caught a fever, and all because of one volcanic pulse from deep within these rivers of fire. There's something humbling about that. The idea that one small breach in the crust can rewrite history. Humans build empires. The mantle merely shrugs. You glide past a plume now, watching it rise from the core mantle boundary, a fiery ghost stretching upward for thousands of kilometers. It's hypnotic, the color of melted bronze, shimmering with light from within. The surrounding rock moves more slowly, like thick clouds of glass, folding and refolding as heat tries to escape. You realize the mantle isn't molten everywhere. Most of it's solid rock that behaves like a slow-flowing solid under extreme pressure. It deforms, creeps, and bends rather than melts. Still, it's always moving, always restless. Somewhere above, those movements manifest as continents sliding, trenches deepening, volcanoes rumbling. You can almost trace the path from deep thermal current to surface catastrophe, like following a fuse through solid stone. Here's a fun fringe tidbit for you. Some researchers speculate that supervolcanoes, those capable of global-scale eruptions, might be connected to mantle plumes that periodically flare up in cycles. The Yellowstone hotspot, for instance, has erupted roughly every 600,000 years. Its caldera today is a scar so large you could fit entire cities inside. When it blows again, and it will eventually, it won't just change the landscape, it'll tint sunsets across continents. Sleep tight with that thought. Of course, most of the time the mantle's work goes unnoticed. It doesn't always explode spectacularly. Sometimes it's patient, sometimes it simply lifts land masses inch by inch, creating broad plateaus or gentle domes. Australia, for example, rides atop a relatively quiet section of mantle, but is still drifting north thanks to the same slow, unseen currents. Every inch of your planet is connected to this hidden system. Every ridge, every valley, every tremor under your bed at night. You might think of the mantle as the planet's subconscious, vast, slow, powerful, and mostly hidden from conscious observation. When it stirs, the surface reacts. When it rests, the crust breathes easier. And just like your own subconscious, it occasionally sends dreams or nightmares to the surface. If you could reach out and touch that molten glow, you'd feel time itself. Every ripple, every bubble of magma, every convection cell is a whisper from the planet's interior saying, "I'm alive." And in that realization comes an odd calm. You're not standing on a dead rock floating through space. You're standing on a living engine, one that's been shaping itself for 4.5 billion years. The continents may look quiet tonight, but deep below, the rivers of fire keep flowing, steady and patient as breath. It's easy to forget that the same warmth that fuels destruction also sustains life. Without those currents recycling carbon, renewing minerals and regulating temperature, there would be no forests, no oceans, no air to breathe. Every sunset, every gust of wind, every step you take, all of it is powered indirectly by the slow dance of heat inside the planet. You tilt your head, listening again for that hum. Maybe it's your imagination, but you think you can hear it. A low, distant rumble, steady as a heartbeat, the sound of a planet dreaming. You drift upward again, leaving the molten glow behind, and the air cools as the pressure fades. The light dims until you find yourself suspended above an endless dark expanse, the ocean floor. It's not the silent void people imagine, it's alive with sound. Tiny tremors click in the distance, hydrothermal vents hiss, and somewhere in the dark, a ridge crackles faintly as new Earth is born. Down here, where sunlight can't reach, the planet is busy renewing itself. You glide along a jagged spine running across the Mid-Atlantic Ridge. It stretches for more than 40,000 miles, a seam in the oceanic crust where magma wells up to create new seafloor. You can almost see the slow ooze of molten rock cooling into basalt, forming ridges and fissures like wrinkles on the planet's skin. The ocean floor isn't old and tired, it's constantly recycling, constantly replaced. The newest crust on Earth lies right here, still warm, still steaming in the cold deep. If you could place your hand on it, you'd feel a faint tremor, like a pulse. That's spreading, the process where two plates move apart and magma fills the gap. It's how the Atlantic continues to widen every year, pushing the Americas farther from Europe and Africa. The movement is subtle, just about an inch annually, but over millions of years it redraws the entire world map. A century ago, when scientists first mapped these ridges using sonar, they couldn't believe what they saw. The floor of the ocean wasn't flat. It was a landscape of mountains taller than the Alps and valleys deeper than Everest is high. It turned out the ocean basins were anything but dead. They were factories, endlessly manufacturing new crust. One early surveyor joked that the Earth has been busy knitting underwater. He wasn't wrong, and at the edges of that knitted fabric are the trenches, the opposite of spreading zones where plates sink back into the mantle. You picture one now, maybe the Mariana Trench, nearly 7 miles deep. If you dropped Mount Everest into it, the summit would still be more than a mile underwater. Down there, in that crushing dark, the Pacific Plate dives beneath the smaller Mariana Plate. It's the planet's slow conveyor belt, recycling the seafloor like cosmic origami. New crust forms at ridges, old crust folds back down at trenches. Historians still argue whether early explorers, those who first crossed the oceans, had any inkling of the forces beneath them. Did they feel the rumble under their ships and wonder if the sea itself was alive? Probably not. They were too busy surviving storms and scurvy. But now, thanks to sonar and satellite gravity mapping, we can see the ocean floor as clearly as if the water were glass. And what a sight it is. Mountains, volcanoes, rifts, scars, a secret world more dramatic than anything above. Here's your quirky fact for tonight. Somewhere near Iceland, the mid-Atlantic ridge actually rises above sea level. You can literally stand on it. In Thingvellir National Park, you can walk between the North American and Eurasian plates, 1 foot on each continent. The ground there is splitting apart by about 2 centimetres each year. So if you ever feel like being in 2 places at once, that's your chance. Though the selfies will definitely require a waterproof phone case. As you move along the ridge, you pass hydrothermal vents. Black smokers, they're called. They spew superheated water filled with minerals, creating clouds that look like smoke against the inky water. Around them, life thrives in ways that defy logic. Giant tube worms, blind shrimp, and bacteria that feed on chemical energy instead of sunlight. It's a world powered not by the sun, but by the planet's own inner heat. If ever there was proof that life and geology are intertwined, it's right here. Life literally hugging the cracks of the Earth. Some scientists even suspect this is where life began, deep in the hydrothermal vents, billions of years ago. Maybe all of humanity's stories, songs and satellites trace back to a single bubble of heat and chemistry in the dark. Imagine that. Your entire species born from the ocean's hidden furnace, nurtured by tectonic breath. You float over the abyssal plains now, vast flat expanses of cooled basalt. The ocean floor here is ancient compared to the ridges, but even ancient is temporary in geological terms. Eventually, it too will be drawn into a trench, melted and reborn. Nothing down here is permanent, not even the quiet. Occasionally a submarine volcano bursts to life, forming an island before waves can erase it again. The Earth's creativity never sleeps, it just works on a longer deadline. A gentle tremor ripples through the water, and you feel it travel beneath you, a reminder of how alive this hidden world is. The crust groans and shifts, echoing through the ocean like the planet's own sigh. It's humbling to realize how little of this humans have seen. More people have stood on the moon than in the deepest parts of the sea. Yet this, right here, is where our planet builds itself, 1 millimeter at a time. The seafloor is the canvas on which the future continents will one day be painted. You let yourself drift a little longer, watching the slow creation of new Earth, feeling the pulse of tectonic time. Somewhere above, continents float serenely, unaware that their foundations are constantly being rewritten. Down here, though, you can sense it, the heartbeat of renewal, slow and steady, ancient and patient. And maybe, just maybe, if you listen closely enough, you'll realize that this hum, the whisper of magma and seawater and shifting crust, isn't just the sound of geology. It's the sound of the planet dreaming itself into shape again and again. You rise from the shadowy ocean depths to a place that feels strangely still, though you know it isn't. The air up here is cool, calm, familiar, but underneath, the clock is ticking. Every tremor, every inch of continental drift, every volcanic sigh is part of a grand timing device that never stops. The planet has its own metronome, and you're standing right on top of it. Scientists call it plate motion rate, but you might just think of it as Earth's heartbeat. The plates move at wildly different speeds. Some creep slower than a fingernail grows, while others dash forward at a blistering pace of 10 centimeters a year. For context, that's about how fast your hair grows, so yes, your scalp is technically keeping geological time. And although that might sound small, multiplied by millions of years, it's enough to shift entire oceans. You picture the Pacific Plate, the heavyweight champion of motion, diving beneath the smaller plates around its edges. Each subduction carries a piece of ancient crust into the mantle, erasing history molecule by molecule. Meanwhile, new crust emerges elsewhere, keeping the cycle alive. It's a delicate choreography, an endless give and take that keeps the surface from stagnating. But lately, scientists have started to wonder if the rhythm is changing. Is the Earth's tectonic clock speeding up or slowing down? The debate is as lively as any academic squabble can be, which is to say, politely furious. Some geophysicists argue that as the planet cools, the mantle's viscosity increases, making it harder for plates to move. Others suggest that the buildup of cold, dense oceanic crust actually speeds things up by dragging plates downward more efficiently. In other words, Earth might either be relaxing or racing depending on which dataset you prefer to believe. Historians still argue whether early measurements of drift, made in the 1970s with primitive satellites, were accurate enough to tell us much at all. Back then, It was like trying to time a snail race with a sundial. Today, with high-precision GPS, we can measure continental motion down to a millimetre a year. Your phone, right now, could probably detect the slow drift of the ground beneath your feet if it cared enough to look, and yet, for all that precision, we still don't know how the planet's internal clock will tick in the future. Some models suggest plate tectonics could one day stop entirely, as the Earth's core cools and its outer shell thickens. Without that motion, mountains would stop forming, volcanoes would quiet, and erosion would flatten everything into one global plain. The Earth would grow old and still, a geologic retirement home. Others think the opposite, that the system might heat up again, driven by radioactive decay, leading to faster drift and more violent collisions. The truth likely lies somewhere between, a planet breathing in irregular rhythm, sometimes calm, sometimes chaotic. It's not just the rate of motion that intrigues scientists, it's how the plates move in fits and starts. You might imagine them gliding smoothly, but they're more like stubborn gears catching and releasing. Stress builds slowly along fault lines, then releases suddenly in earthquakes. The pattern is irregular, unpredictable, and maddeningly beautiful in its chaos. The Earth doesn't tick evenly. It stutters, hesitates, then lurches forward, each pulse a reminder that time in geology is measured not in seconds, but in ruptures. Here's a quirky fact for your sleepy brain. The fastest moving tectonic plate on Earth is the Cocos Plate, off the west coast of Central America. It zips along at nearly 10 centimeters per year. That may not sound impressive, but for a slab of rock larger than Texas, it's a sprint. If continents had egos, this one would be bragging endlessly. Meanwhile, the slowest plate, the Eurasian, barely moves at all. It creeps along at a few millimeters per year, content to let others do the dramatic work. You could say it's the introvert of tectonics, preferring to sit quietly and judge the rest of the crust for being too excitable. Sometimes you wonder if the planet feels these shifts. If the mantle has any sense of time, it must experience existence in centuries the way you experience seconds. Each oscillation, each shift, each tremor, it's all part of a rhythm that spans billions of years. The continents have danced this way since Earth first cooled enough to form crust. One mainstream historical tidbit: ancient Chinese astronomers once kept careful records of earthquakes, long before they knew what caused them. Those records now help modern scientists reconstruct tectonic motion over thousands of years. Imagine that. Someone with a candle and parchment, unknowingly contributing to a theory that wouldn't exist for 2 millennia. The Earth's clock keeps time for everyone, even those who never knew it was ticking. The irony, of course, is that while the Earth measures time in inches and centuries, we humans measure it in deadlines and heartbeats. Your entire life passes in less than a geological blink, and yet you exist within a story that stretches from molten chaos to mountain calm. You're part of the ticking. Every step you take slightly alters the load on the crust, however minuscule. Every city built adds a tremor to the system. You're not just living on the clock, you're adding seconds to it. It's easy to feel small in that context, but there's something soothing about it too. The planet doesn't rush, doesn't panic. It just moves. A centimetre here, a millimetre there, and before long, an ocean is born. If only human clocks ran on such patience. Somewhere under your feet, a ridge is widening, a trench is deepening, a mountain is growing taller. You won't hear it, but you're part of it all the same. The world's slowest clock keeps ticking, and you, lucky little observer, get to listen. You close your eyes and let that thought settle. The gentle hum of time, steady as breath, stretching beyond lifetimes. The crust moves, the mantle flows, the planet counts the years not in rotations, but in rearrangements. And whether the clock is speeding or slowing, it keeps perfect rhythm with the universe itself. You can feel it now, the subtle, creeping motion that never stops. The continents are on the run again, rearranging themselves like pieces of furniture in a house that refuses to stay tidy. From your vantage point high above the spinning globe, you can almost see them drifting, each with its own quiet urgency. You trace their paths in your mind, Africa inching north, Australia sprinting toward Asia, the Americas slowly sliding west as if trying to escape the Atlantic's widening grin. Earth's plates are never content. They've been moving for billions of years, and they're not slowing down anytime soon. Each continent carries a story of separation and reunion, like old friends who can't quite stay apart. The Atlantic Ocean, still young by geological standards, is stretching wider every year, while the Pacific shrinks, its edges devoured by subduction zones. You realise that oceans are temporary things, beautiful, vast, but ultimately doomed to close again. If you could fast-forward time, watching Earth's next 250 million years unfold in a single heartbeat, you'd see continents sliding and colliding until, at last, they merge into one enormous supercontinent. Scientists have already named it Amasia, a future landmass where Asia and the Americas embrace across the vanished Arctic, while Africa and Australia join the party from below. The Pacific will be gone, swallowed like a puddle under the weight of tectonic inevitability. Of course, not everyone agrees on that particular vision. Historians still argue whether Amasia will really form at the top of the world, or if we'll instead get Pangaea Proxima, a more equatorial version with a giant desert interior. The debates are lively, models clash, simulations disagree, and geologists throw politely worded shade at conferences. But whether the future map leans north or south, the message is the same. The continents are gathering again. You glance toward Australia, lonely, determined, and moving faster than most. It's drifting north at about 7 centimeters a year, one of the speediest continental plates out there. At that pace, it'll slam into Southeast Asia in roughly 50 million years. The collision will crumple mountains higher than the Himalayas, raise new island chains, and close the last remnants of today's Pacific. For now, though, the only sign is a scattering of quakes and a few restless volcanoes humming beneath the sea. Africa is doing its own stretch routine. Along the East African rift, the continent is slowly splitting into two. You picture it like a faint scar running through Ethiopia, Kenya, and Tanzania, a fracture line widening so gradually that locals hardly notice. But one day, perhaps tens of millions of years from now, seawater will pour in, birthing a brand new ocean. Imagine standing there when it begins, the land beneath you sinking, the air tasting faintly of salt, the birth of a new sea, slow, majestic, unstoppable. Here's a quirky tidbit. The world's GPS networks already have to be adjusted every year because of this drift. Your phone's map isn't wrong because of bad signal. It's wrong because the Earth moved. In Australia, surveyors correct location data by about 7 centimeters annually, so the continent's coordinates match up with satellites. Every time you navigate, you're compensating for tectonic wanderlust. You hover now above the Atlantic, watching as North and South America drift steadily westward, carried by the push of magma welling up along the mid-ocean ridge. The ocean floor here is growing, expanding like dough in slow fermentation. Eventually, the Americas may swing around and crash back into Asia's flank. Picture the Andes stretching into Alaska, or Siberia sharing a border with Brazil. Geography teachers of the future are going to have a rough time, and through all this you realise something quietly profound. Continents aren't passengers, they're part of the machine. Their weight affects how the mantle flows, their motion alters the balance of the planet's rotation, and even the distribution of water and air changes as they shift. When Africa moves north, it changes ocean currents. When the Himalayas rise, they alter wind patterns. The continents don't just move on Earth, they move with it. One mainstream historical note: in the 1960s, when plate tectonics theory finally gained acceptance, scientists began building computer models to predict these future supercontinents. Those early simulations ran on machines the size of living rooms, and yet their output, grainy, pixelated animations of drifting continents, looked eerily similar to modern high-resolution models. It turns out, even with crude data, the planet's intentions were clear. You pause for a moment, gazing at this slow rearrangement, and it hits you. The Earth isn't changing into something new, it's changing back into something familiar. It's done this before, countless times. The crust gathers, fuses, fractures, scatters, and gathers again. It's a planetary heartbeat, a pattern older than any life it supports. And if that thought doesn't make you feel small enough, consider this fringe theory. Some researchers propose that each supercontinent cycle subtly alters Earth's rotation speed and even its magnetic field, setting off global feedback loops that influence climate and possibly mass extinctions. The continents move, the climate shifts, and life either adapts or vanishes. Tectonics, it seems, doesn't just sculpt the land, it edits the story of life itself. Still, for all its power, this process feels oddly peaceful. The continents don't rush, they slide, inch by inch, letting time do the heavy lifting. You breathe in sync with that slow motion, imagining yourself riding one of these plates for the next 100 million years, watching coastlines vanish, volcanoes bloom, mountains collapse into plains, and new oceans yawn open like sleepy mouths. Somewhere deep below, the mantle hums its endless tune, the same rhythm that's been playing since the world first cooled. You realize the planet doesn't just rearrange for the sake of chaos. It rearranges because motion is what keeps it alive. You drift back towards solid ground, if anything on this restless planet can truly be called solid. Beneath your feet rise mountains, those great wrinkles of the earth, frozen waves in a sea of stone. They look eternal, unshakable, but you know better now. They are simply the scars left behind when continents collided, the living record of tectonic arguments that never quite ended. You trace your fingers across the granite of a mountain wall. The layers are tilted, folded, and twisted, like pages in a book that's been reread too many times. Each layer tells a story. Sand once laid down by an ancient sea, lava from an old volcano, sediment crushed under unimaginable pressure. These rocks remember. They carry the memory of vanished oceans, extinct species, and climates so alien you can hardly picture them. Mountains are memory, solidified. The Himalayas are the most famous example of this living archive. Formed about 50 million years ago when India ploughed into Asia, they're still growing today, an inch or two a year. That's faster than your fingernails. The collision zone runs for thousands of miles, a boundary where the Earth constantly negotiates how much pain it can bear before it cracks again. Every few decades, a quake ripples through the region as the crust releases its pent-up tension, a reminder that these peaks are not statues, they're works in progress. Historians still argue whether early travellers, those who first gazed upon the Himalayas or Andes, understood that these walls of stone were not ancient ruins but living creations. To them, mountains were eternal, the unchanging backdrop of myth and prayer. It took centuries before science whispered the truth. Mountains are fleeting, just very slow about it. You climb higher in your imagination, your breath growing thin as the air cools. From this altitude, the land below seems to ripple, valleys flowing between peaks like slow rivers of stone. Far beneath, tectonic forces grind and push, feeding the cycle that raises these ranges. One day, erosion will wear them down again, carrying their dust to the sea, where new layers will form, waiting to be lifted once more. Even the tallest summit is already halfway to becoming sand. There's something comforting in that idea. The world doesn't waste anything, it just rearranges. Mountains crumble, oceans fill, continents drift, and through it all, the materials of creation stay in motion. You're walking on atoms that might once have been part of a coral reef, or a volcanic plain, or even another mountain entirely. Here's your quirky tidbit for this stretch of the journey. The Appalachian Mountains in North America were once part of the same range as the Scottish Highlands and the Atlas Mountains of Morocco. They formed hundreds of millions of years ago, when the continents were locked together in the supercontinent Pangaea. When the landmasses drifted apart, the mountain chain split too, leaving its broken pieces scattered across 3 continents. So next time you're hiking in the Appalachians, you're walking the same ancient ridge that once crossed the Atlantic. It's strange to think of continents as puzzle pieces still trying to remember how they used to fit. The rocks themselves hold the clues, identical mineral bands matching fossils, magnetic traces that line up across oceans. It's as though the Earth left breadcrumbs in the crust, daring us to follow. You reach a ledge and pause, looking out across a vast range bathed in moonlight. It's easy to romanticize mountains, the way they stab at the sky, the way clouds curl around their shoulders. But they're also ruthless. Every meter of elevation represents the crushing of the rock, the grinding of plates, the shattering of ancient seabeds. Beauty born of violence, carved by time's steady hand. The Andes, for instance, were built as the Nazca Plate dove beneath the South American plate. That subduction zone fuels a string of volcanoes that trace the continent's spine like fiery vertebrae. In every plume of smoke you can see the planet exhaling. The same process that forged those summits also triggers devastating earthquakes. Life clings to the edges of catastrophe because that's where creation happens fastest. As you breathe in the thin air, you realize that these mountains are the only reason we even have weather as we know it. When ranges rise, they redirect wind and rain. The Himalayas created the monsoons. The Andes sculpted the deserts of Chile. Mountain ranges don't just remember the past, they rewrite the present, and they'll keep doing so as long as the plates keep colliding. You crouch to pick up a pebble, one tiny fragment of the range. Inside it lie minerals that once crystallized under immense pressure, molecules rearranged by heat and time. Hold it to your ear. No, you won't hear the ocean, but you might just hear the whisper of 1 billion years. It's humbling, isn't it? To realize the ground beneath you is older than language, older than life itself, yet still in motion. The mountains around you seem silent, but they hum quietly with tectonic tension. The vibration is constant, too low for your ears, but real enough to rattle instruments deep in the ground. If you linger long enough, you might start to sense it, the slow heartbeat of the mountains, the deep exhale of the earth as it shifts under its own weight. They are not still. They are breathing, dreaming, remembering. Somewhere far below, another range is being born, unseen beneath the ocean or buried under layers of sediment. The cycle continues. Every peak you see tonight will one day lie beneath waves, ground to dust and reborn as another mountain in another age. And as you stand there, surrounded by the ghosts of ancient continents, you realize that the world's history isn't written in books. It's written in stone. The mountains fade behind you as you descend toward flatter ground. Valleys where the crust flexes and breathes, where pressure gathers invisibly for centuries before the planet suddenly remembers to exhale. Down here, the drama of motion doesn't roar like volcanoes or blaze like magma. It waits. It hums under your feet, storing centuries of strain in silence. Until, one day, it doesn't. Every fault line on Earth is a sleeping beast, curled beneath cities and fields pretending to rest. You tread carefully over one now, tracing the jagged scar of a transformed boundary, where two plates grind past each other sideways instead of colliding. The San Andreas Fault in California is the most famous of these, a restless seam that creeps and jerks, reshaping landscapes inch by inch. To stand above it is to stand between two worlds, the Pacific Plate on one side, the North American on the other. You're literally spanning a moving border. People talk about earthquakes as if they arrive out of nowhere, but the truth is the Earth gives plenty of notice. It just speaks a language we haven't yet learned to translate. For decades, scientists have listened to the planet's subtle murmurs, microseisms, electromagnetic pulses, ground deformations smaller than a coin's width. The Earth rehearses its quakes in miniature long before the main event. Historians still argue whether the ancient Greeks or Chinese recorded the first earthquake prediction attempt. The Greeks blamed Poseidon, of course, while the Chinese took a more inventive approach. In 132 AD, Zhang Heng built the first seismoscope, a bronze vessel with 8 dragons, each holding a ball in its mouth. When an earthquake struck, one ball would drop into the mouth of a bronze frog, showing the direction of the quake's origin. Imagine that, a mechanical dragon alarm 2,000 years before modern seismology. The irony is that for all our satellites and sensors, we still can't predict exactly when the next big one will strike. We can measure the stress, we can map the faults, we can say soon, but never now. It's as if the Earth guards that final bit of mystery for itself. You close your eyes and listen. The air is perfectly still, but the ground beneath you isn't. It shifts in imperceptible slow motion, creeping along a process called aseismic slip, movement so gradual that it releases no destructive energy. It's the planet's way of stretching without snapping. Unfortunately, not all faults are so patient. Some hold on until the pressure becomes unbearable, then release it in a single catastrophic jolt. You imagine that moment. The quiet first, a pause so deep it feels like the Earth is taking a breath. Then the rupture begins, spreading along the fault at several kilometers per second. Buildings shudder, roads ripple like waves, rivers briefly reverse course. Time itself seems to stagger. The energy unleashed by a major quake is staggering. A magnitude 8 earthquake releases about the same energy as 1 billion tons of TNT. That's roughly the power of all the nuclear weapons on Earth, detonated at once but deep underground. And yet, it all begins with a movement of rock over a few meters, a reminder that in geology, scale is everything. A quirky tidbit to keep you awake for one more minute. Scientists once tried to trigger a controlled earthquake using pressurized water injections along a fault near Denver in the 1960s. They succeeded, but not exactly as planned. The small, frequent quakes they created spooked locals and eventually led to the study of how human activity can awaken sleeping faults. It turns out the planet really doesn't appreciate meddling. You run your hand along a cliff face exposed by centuries of motion. The rock layers on either side don't line up. They've slid past each other by several meters. Somewhere in those gaps lies evidence of every ancient tremor that's ever passed through. Faults remember, even when people forget. At night, the world grows quiet, but the Earth's movements continue. Every second, hundreds of tiny quakes ripple through the crust across the globe, most too weak to feel. The planet twitches in its sleep, releasing tension in whispers rather than screams. Seismographs record them as gentle wiggles, the Earth's equivalent of shifting in bed. You think of the cities built atop these lines of tension: Tokyo, San Francisco, Istanbul, Mexico City. They shimmer in the night, unaware of the immense forces idling below. Engineers design, reinforce and hope, but there's no guarantee. The planet isn't cruel, it's simply indifferent. It has its own schedule, and it doesn't check in with ours. Still, earthquakes aren't just agents of destruction. They're also sculptors. They lift valleys, tilt coastlines, and form new lakes in minutes. After the 2011 quake in Japan, entire sections of the country permanently shifted eastward by several meters. GPS markers had to be moved, maps had to be redrawn, the land itself had changed its mind. You can almost hear it now, that faint distant rumble, the low growl of rock rearranging itself. It's unsettling, yes, but also strangely comforting. There's honesty in it. The Earth never pretends to be still. It creaks, sighs, releases. It breathes through fault lines. You crouch, placing a palm on the ground. The soil is cool and, for a heartbeat, utterly still. Then, maybe, just maybe, you feel the slightest pulse beneath your hand. A hint of motion, a whisper from miles below. The Earth doesn't mean to startle you. It's just rolling over in its sleep. You're still crouched, your hand pressed to the ground, when the faint pulse below shifts. Warmer now, a slow radiating breath rising from deep within the crust. You follow it downward in your mind, sinking through layers of rock until you reach the molten chambers where the Earth exhales fire. The air is heavy with sulfur, the walls glow faintly red, and the silence hums like a held note. You've arrived at the planet's forge, the hot breath of volcanoes. Volcanoes are where the planet speaks out loud. After centuries of subterranean whispering, all the pressure, all the heat, all the chemical poetry of the mantle finally finds its voice. You can picture it vividly, magma surging upward through fractures, gases hissing, the Earth's surface swelling like a held lung. Then, release. A column of ash and flame, a plume piercing the sky, molten rock cascading down like liquid lightning. It's beautiful in a reckless, terrifying way. The paradox, of course, is that volcanoes destroy and create in equal measure. They can bury entire cities beneath ash. Pompeii learned that lesson the hard way in 79 CE. But they also build new land, new soil, new worlds. Every tropical paradise you've ever seen, Hawaii, Iceland, the Azores, exists because somewhere beneath the waves, a volcano got ambitious. There's an undeniable thrill in standing near one. The air smells faintly metallic, tinged with steam and life's raw chemistry. You can hear water hissing where it meets the lava, the sharp crackle of cooling stone. The ground trembles underfoot, not violently but rhythmically, like the steady beat of a massive heart. You realize you're listening to convection in real time, mantle energy becoming surface art. Here's your mainstream historical moment. The 1883 eruption of Krakatoa. It was one of the loudest sounds ever recorded on Earth, heard nearly 3,000 miles away. Barometers around the world twitched as the shockwaves circled the globe multiple times. The explosion threw so much ash into the atmosphere that sunsets turned blood red for months. Painters in Europe captured those eerie skies without realizing they were painting the fingerprints of an Indonesian volcano. And here's your quirky fact for tonight. The ancient Romans, in their endless creativity, used volcanic ash from Mount Vesuvius to make concrete. That's why many of their structures, harbours, aqueducts, temples, still stand 2,000 years later. The secret ingredient in their immortality: pulverized volcano. So in a strange twist, destruction gave birth to durability. Volcanoes are, in many ways, the planet's pressure valves. The crust holds in the Earth's internal heat, but that heat always finds a way out. Sometimes it seeps gently through fumaroles or geothermal vents. Other times it roars out of calderas that span miles. The balance between quiet and cataclysm is delicate. Too much pressure, and the world reminds us who's really in charge. Historians still argue whether ancient cultures understood volcanic cycles or simply read divine moods into them. Some Polynesian myths describe mountains as islands that breathe fire. The Japanese saw Mount Fuji as both a goddess and a gateway to the afterlife. The Maya linked eruptions to the wrath of gods, yet also to fertility, lava as the blood that renewed the land. For all our satellites and seismic networks, those myths still hold truth in metaphor. Volcanoes are both destroyers and givers of life. You walk along a cooled lava field, the rock beneath your feet sharp and glassy. It crunches like brittle sugar. The air smells faintly of iron. A few stubborn plants have already begun to take root, sending green tendrils into cracks where ash has turned to fertile soil. Life wastes no time here. It rushes back as soon as the planet's temper cools. Somewhere in the distance you spot a glowing crater rim. The molten lake within churns like a restless thought, every ripple a whisper of heat from thousands of kilometers below. You can almost imagine the magma murmuring stories of its journey upward, of ancient sea floors melted and reborn, of trapped gases longing for the open sky. Volcanoes also connect the deep earth to the air above in the most direct way possible. When they erupt, they release carbon dioxide, sulfur dioxide, water vapor, and trace metals. Those gases shape climates, sometimes gently, sometimes catastrophically. A single massive eruption can cool the entire planet for years, veiling sunlight in aerosols, yet the steady trickle of volcanic gas over eons is what maintains the atmosphere's balance. Too little volcanic outgassing and Earth would freeze. Too much, and it would bake. Once again, the planet walks its fine, fiery line, and sometimes volcanoes whisper instead of roar. Iceland's Eyjafjallajökull, for instance. Remember that name everyone struggled to pronounce back in 2010? Didn't explode violently, but its ash grounded flights across Europe for weeks. The modern world discovered that even a mild sneeze from the planet can paralyze global travel. You pause, standing at the edge of a caldera as a low rumble rolls beneath you. The sound is deep, almost comforting, like a giant sigh. For a moment you think of all the eruptions past and future, each one a punctuation mark in Earth's story. The crust cracks open, the mantle breathes, and the surface rearranges itself once again. It's oddly soothing to realize that this cycle of fire has been steady for billions of years. The same forces that terrified early humans built the ground you walk on. The ash that buried Pompeii helped form the soil that grows vineyards today. Out of every explosion comes renewal. The planet knows no waste, only transformation. As you turn away from the glow, you glance up at the night sky. The stars shimmer, cold and distant, yet you can't help but see the reflection of volcanoes in them. The same dance of heat and creation happening on a cosmic scale. The Earth, you realize, is just one spark among billions, each with its own heartbeat of fire. You breathe in the warm, sulfur-scented air and smile. Even destruction, in the grand scheme of things, is part of the planet's lullaby. You step away from the crater's red glow and find yourself by the edge of an ancient coastline. Stone and water forever locked in a tug-of-war that neither wins for long. The air smells of salt and minerals, and the waves whisper over pebbles smoothed by centuries of persistence. Here, where water meets stone, the surface of the planet tells its quietest and most patient story. The meeting line between land and sea is not a border, it's a negotiation in motion. Every tide, every raindrop, every grain of sand carried by the wind is an amendment to the planet's ongoing treaty with itself. You look down and see the faint shimmer of quartz and mica in the wet sand. Tiny fragments of mountains ground to dust and carried here by rivers that remember their source. This is erosion in its final act, the slow unravelling of everything solid. Yet even as the land yields to water, tectonics conspires to lift it again. The same forces that grind continents together push coastlines upward, raising new cliffs as fast as waves tear them down. The result is balance, uneven, irregular, but balance all the same. Somewhere a beach erodes, somewhere else an island rises. The planet never loses, it just redistributes. Historians still argue whether ancient mariners, those who charted the world long before GPS, ever grasped that the coastlines they mapped were temporary. The Phoenicians, the Greeks, the Polynesians, they left meticulous records of shores that have since vanished beneath the sea or risen high above it. Entire ports, once bustling with ships, now sit miles inland, marooned by uplift. Alexandria's old harbour sleeps underwater. The Bay of Naples has swallowed Roman villas whole. The maps were faithful, the Earth simply changed her mind. You crouch to scoop up a shell. It's smooth, pearly, fragile, and yet in its spiral is a story of adaptation. The creature that once lived inside built its home from minerals drawn from seawater, minerals that began as rock deep in the crust. The cycle closes. Mountains dissolve, rivers deliver their essence to the sea, creatures borrow that essence to build skeletons and shells, and when they die, their remains settle into sediment that will one day harden into stone again. The ocean is a sculptor and a recycler. A quirky fact drifts through your mind. During the reign of Cleopatra, the sea level along the eastern Mediterranean was several meters lower than today. Whole stretches of the Nile Delta that once grew grain for empires are now submerged. And off the coast of Japan, tectonic subsidence has drowned entire forests, their preserved trunks still standing upright beneath the waves like wooden ghosts. The planet archives its drafts in layers of silt. You walk along the shore, watching how every wave rewrites the beach's outline. It's hypnotic. The repetition, the rhythm, the faint fizz where foam meets sand. You realise that this endless rearranging on a small scale mirrors the same motions of the plates below. Erosion and tectonics are partners in a waltz. One builds, the other dismantles, and together they keep the surface alive. Without erosion, mountains would grow so tall they'd distort the planet's gravity. Without uplift, the world would drown beneath its own sediments. Creation needs collapse to stay interesting. You remember that beneath the water, the continental shelf stretches outward for miles before dropping into the abyss. Out there, submarine canyons cut through the seabed like scars, carved by ancient rivers that once flowed across dry land. When sea levels rose after the last ice age, those river valleys filled with water, becoming fjords and estuaries. The coastlines we love today are the ghosts of drowned landscapes. Standing ankle deep in the surf, you feel the subtle vibration of distant waves colliding with the continental slope. The sound isn't loud, it's more like a heartbeat translated through liquid. You imagine all the tiny collisions happening here, grains of sand striking rock, water molecules striking air, tectonic plates striking each other in slow motion far beneath. Everything collides, everything transforms. A mainstream historical tidbit, the study of coastal change became urgent after the 1755 Lisbon earthquake and tsunami, one of the first disasters to be analysed scientifically rather than theologically. It destroyed most of the city, killed tens of thousands, and sent waves racing across the Atlantic. In its aftermath, philosophers like Voltaire and scientists like Kant debated whether natural law, not divine wrath, was to blame. From that tragedy, geology gained a foothold as a discipline, and humanity gained a little humility. The irony is that tsunamis, those terrifying walls of water, are themselves born from tectonics. When a plate suddenly shifts beneath the ocean, the displaced water carries the message to the shore. The waves you're watching tonight are gentle messengers. Their monstrous cousins announce that the planet has twitched. Every coastline on Earth lives with that knowledge, quietly pretending not to. You pick up another shell, place it in your pocket, and notice how the horizon seems impossibly far. Out there, the sun dips lower, staining the water copper and gold. The line between sea and sky blurs until you can't tell where one ends and the other begins. That's the trick of the coast. It convinces you of permanence even as it rearranges itself grain by grain. Somewhere behind you, mountains are rising. Somewhere ahead, an ocean trench yawns wider. And here, at the seam between the two, the planet performs its most delicate balancing act. You breathe in the salt air, close your eyes, and listen to the waves undoing the continent in slow, perfect rhythm. For all its motion and chaos, the Earth somehow always finds equilibrium, at least for a while. The land yields, the sea takes, the plates shift, and you, caught in the middle of it all, get to witness the quiet beauty of perpetual change. You leave the shoreline behind and wander inland to a windswept plain where the rocks beneath your feet shimmer faintly with iron. The land here feels ancient in a different way, not because of mountains or oceans, but because of what it remembers. Each stone holds a trace of the planet's magnetic heartbeat, frozen in place like a compass that once pointed elsewhere. These are magnetic time capsules, silent witnesses to the wandering of continents and the restless shifting of Earth's magnetic poles. You pick up a chunk of basalt, dark and heavy. Within it are tiny crystals of magnetite, microscopic needles that once aligned themselves with the direction of Earth's magnetic field as the lava cooled. Now, millions of years later, those tiny compasses are locked in place, their orientation revealing which way north used to be. It's astonishing, really. The seafloor itself serving as the planet's long-term diary, each volcanic layer recording another chapter in the story of drift. You close your eyes and imagine watching the magnetic poles dance through time. Every few 100,000 years they swap places, north becomes south and south becomes north. These reversals are irregular, unpredictable and utterly fascinating. Historians still argue whether early scientists first noticed them in seafloor samples or in the magnetized remnants of ancient lava flows on land. Either way, it was a revelation. Proof that not only do continents move, but the planet's very sense of direction isn't constant either. In the 1950s, geologists surveying the ocean floor discovered symmetrical stripes of magnetic polarity running parallel to mid-ocean ridges. Each stripe represented a period when the magnetic field pointed one way or the other, like alternating black and white bars on a barcode. That barcode became the smoking gun for plate tectonics. The planet had literally recorded its own motion in magnetic ink. Here's a quirky fact for your late-night imagination. During a magnetic reversal, the field doesn't just flip overnight. It weakens, fragments, and wanders chaotically for thousands of years before finding its new alignment. Compasses would behave like confused dancers, spinning lazily instead of pointing anywhere useful. Birds, whales, and even bacteria that rely on magnetic navigation might drift off course. Thankfully, humans have GPS, though if the satellites ever fail, we might find ourselves accidentally reinventing Viking-style navigation. You picture the molten core of the planet, the great iron heart responsible for this magnetic symphony. Deep within, liquid metal churns in enormous convection currents, generating electric fields that, in turn, create the magnetic one. It's a self-sustaining feedback loop called the geodynamo, and it has protected life on Earth for billions of years by deflecting cosmic radiation. Without it, the solar wind would strip away our atmosphere as it did Mars's long ago. You tilt your head and imagine hearing that field, not as a physical sound, but as a vibration of safety, an invisible shield wrapping the planet in gentle magnetism. It hums through your body, aligning your iron atoms just slightly, whispering, "You're inside the field. You're home." But the field isn't perfect, and it's not permanent. Over the last 2 centuries, scientists have noticed it weakening, by about 10% since the 1800s. A particularly strange region, called the South Atlantic Anomaly, has an unusually low magnetic strength, causing satellites that pass over it to glitch and stumble. Some researchers think it could be the early sign of an upcoming reversal. Others insist it's just a wobble, nothing more. The debate continues quietly, as geophysicists squint at magnetic maps like fortune tellers, reading tea leaves made of molten iron. A mainstream historical tidbit. When early compasses reached Europe from China around the 12th century, sailors noticed that north wasn't quite where the stars said it should be. That small difference, the magnetic declination, was the first human hint that Earth's magnetic field drifts over time. What began as a navigation nuisance turned out to be a planetary signature of motion deep below. You can't help but smile at the irony. Humanity spent centuries building instruments to find true north, only to learn that north itself keeps wandering off like an absent-minded traveller. The magnetic pole currently migrates about 40 kilometres a year across the Arctic. At this rate, within a few decades, it will slide from Canada to Siberia. The planet, it seems, doesn't believe in staying organised. You crouch beside a basalt outcrop and trace your fingers along its striations. The iron minerals here point south, though you're standing in the northern hemisphere. It's disorienting and delightful, a reminder that time doesn't just move forward, it swirls, reorients and doubles back on itself. Each layer of rock beneath you holds a frozen compass needle, a record of a world that once faced a different way. If you could peel back the crust and unroll the seafloor like an ancient scroll, you'd see those magnetic stripes stretching for tens of thousands of miles. Proof that the continents are not drifting aimlessly, but in rhythm with a magnetic beat that's been playing since the planet first cooled. The field reverses, the seafloor records it, and together they form the pulse of deep time. Here's something to dream about. Every time the magnetic poles flip, the auroras, the northern and southern lights, might dance across completely new skies. Imagine green curtains of light rippling over the equator, or red halos shimmering above tropical islands. It would be beautiful chaos, the sky itself participating in the planet's slow choreography. You lean back, feeling the pull of the magnetic field on the compass in your pocket. The needle quivers slightly, trembling between the present and the past. It's a tiny movement, but in it lies the story of the Earth's restless heart. Iron flowing, fields shifting, plates gliding, oceans forming. The planet doesn't simply move in space, it moves within itself. And as the stars wheel overhead, indifferent and eternal, you realize that even the ground you trust most, the direction you call north, is just another temporary arrangement in a world that never stops rearranging. You sit on that iron-dusted plain a moment longer, letting the image of those magnetic stripes fade until the planet itself seems to breathe under you again. The hum returns, slower now, deeper, as if Earth were whispering the oldest refrain it knows: gather, scatter, gather, scatter. You're about to witness that rhythm in full, the supercontinent cycle, the grand inhalation and exhalation of the crust. It begins quietly, always quietly. A few rifts open in a great landmass, magma seeps upward, and water rushes in to fill the cracks. What starts as a trickle becomes an ocean. What was one continent becomes many. Hundreds of millions of years later, those fragments drift back together, closing the wounds they once made. Each cycle lasts about 500 million years, and the planet has likely completed 6 of them since it first solidified. The names read like poetry carved in stone: Valbara, Kenorland, Columbia, Rodinia, Panotia, Pangaea, and the next, still unborn, perhaps Amalgia or Pangaea Proxima. Each one was a unique arrangement of the same old crust, a rearranging of familiar actors on a shifting stage. The rocks may change partners, but the dance remains the same. Historians still argue whether these cycles run on a fixed timetable or respond to deeper, unpredictable forces in the mantle. Some models suggest that supercontinents form above vast regions where the mantle is unusually cool, drawing plates inward like a geological vortex. Others believe mantle plumes rising from below push them apart instead, meaning the whole process might be more chaotic than cyclical. The truth, as usual, lies somewhere between design and improvisation. You imagine standing on Rodinia, 900 million years ago. The air is thin and the land bare, no forests yet, just rock and bacterial mats gleaming in shallow seas. You could walk from pole to pole without crossing an ocean, though it might take you a few million years. When Rodinia broke apart, it triggered climatic extremes. Glaciers reached the equator in what scientists call snowball Earth. It's almost funny. Earth's biggest continental breakup led to its coldest freeze. The planet likes its irony served cosmic. A quirky fact to tuck into your pillow tonight. When Pangaea existed about 250 million years ago, you could have walked from New York to Morocco without getting your feet wet. The Appalachian Mountains continued straight across the Atlantic into Africa. Somewhere beneath the Sahara lie the roots of Appalachia's twin peaks, still fused in memory. Supercontinents reshape everything: climate, ocean currents, even evolution. When land gathers, the interior dries into vast deserts. When it disperses, coastlines multiply, and life explodes with diversity. The breakup of Pangaea opened new seas that became cradles for modern marine life. You owe the existence of whales, coral reefs, and perhaps your own species to the restlessness of tectonic drift. You picture the future now, fast-forwarded by imagination. The Pacific closes as the Americas slide westward. Asia pivots north to meet them. Australia tucks itself beneath Southeast Asia, welding into a single enormous continent around the top of the planet. The Arctic Ocean vanishes. Mountain ranges soar where Alaska meets Siberia. Perhaps a few remnant seas glimmer in the interior, salty mirrors for a redder sun. Amasia, gleaming like a stone crown at the roof of the world. And long after that, maybe 200 million years beyond, the crust will sigh again and begin to tear it apart. The pattern will repeat, indifferent to whatever civilization happens to be standing in the way. Even continents have lifespans. Even mountains are temporary. The only permanent thing on this planet is motion. A mainstream historical note: the idea of the supercontinent cycle was only formalized in the late 20th century after decades of fieldwork and computer modeling. Before that, scientists thought Pangaea was a one-time event, a lucky or unlucky alignment. It took patient geologists, many of them poring over paleomagnetic data from rocks older than imagination, to realize that Pangaea was just the latest verse in a very old song. You lie back staring up at a sky that seems fixed, but you know better now. The stars themselves are drifting. The constellations will one day be unrecognizable. Above, the cosmos rearranges. Below, the crust keeps time, its motion all the way down, all the way out. The wind softens. The hum of the earth slows to a lull, as if the planet itself is tired from all its rearranging. You imagine continents sliding together like tired puzzle pieces, oceans sighing closed, mountains folding gently to rest. The air grows heavy with the scent of iron and salt, the two eternal ingredients of creation. You can almost feel the pulse of the next supercontinent beneath you, still unborn, still dreaming in magma. It beats slow and steady, a planetary heartbeat measured in millions of years, and as you listen, your own heartbeat syncs with it for just a moment, small but perfectly in rhythm. Because you too are part of this cycle. Every atom in your body, iron from ancient magma, carbon from buried seas, calcium from vanished reefs, has been through countless rounds of gathering and scattering. You are, in a literal sense, a fragment of every supercontinent that ever existed. So when the Earth breathes in again and the continents drift back together, a few of your atoms will be there, folded into the mountains, glimmering in the sand, humming in the planet's slow, patient rhythm. And with that thought, you exhale. The sound blends perfectly with the world's own sigh. The crust quiets, the mantle murmurs, the heartbeat continues. You stay still a while, letting that heartbeat echo through you until another rhythm starts to overlap. The faint, circling wonder of magnetism that wraps the planet like invisible silk. The supercontinents shift below, but above the molten core, the poles themselves start to drift. They've always wandered. They always will. The North Magnetic Pole, for instance, is currently making its way from the Canadian Arctic towards Siberia, about 40 kilometers a year, as though it's chasing a private curiosity across the top of the world. The South Magnetic Pole follows its own erratic path, half a planet away, always slightly out of sync. The field between them isn't a perfect dipole. It wobbles, folds, and stretches like a restless blanket. It's what keeps your compass twitching and the aurora curtains swaying over polar skies. You imagine watching this migration from orbit, a slow drift of invisible lines curling and tightening like smoke rings. Every living creature that senses magnetism feels it too. Whales steer their migrations by it. Birds feel it in their skulls. Even honeybees detect its faint tug through particles of magnetite in their tiny bodies. You, though mostly blind to it, are wrapped inside that field every moment of your life. Historians still argue whether the first true measurements of pole drift came from the 16th century explorers mapping the North Atlantic or from the logbooks of Chinese navigators centuries earlier. In either case, humanity has been quietly chasing an invisible moving target for half a millennium. Every few decades, mapmakers must update magnetic north, so compasses still make sense. The poles move faster than bureaucracy. You kneel and draw a small compass from your pocket. The needle flutters, quivering as if it can sense your attention. Beneath the Arctic ice, molten iron in the outer core is swirling eastward, generating currents that pull the field along with it. That liquid motion, called the geodynamo, is the planet's internal storm, a hurricane made of metal. Sometimes you imagine what it must look like. Colossal eddies glowing faintly orange, churning around the solid inner core like waves around a lighthouse. And here's a quirky little thought for tonight. In 1905, a Norwegian mathematician proposed that fluctuations in Earth's magnetic field might slightly alter the planet's rotation speed. A few nanoseconds faster here, a few slower there, imperceptible to us, but enough to keep timekeepers and astronomers nervously checking their equations. The Earth, in other words, has a magnetic mood swing. As you gaze north, you think of the aurora, that shimmering border where magnetism meets solar wind. When charged particles from the sun crash into the upper atmosphere, they follow the field lines down to the poles, tracing them in luminous greens and purples. It's the closest thing the planet has to a halo. On quiet nights, the aurora whispers across the sky like phosphorescent smoke, flickering in rhythm with the invisible field below. You wonder how it must have looked to the first humans who saw it. No wonder they filled the sky with myths, souls of the dead dancing, gods kindling fires, celestial foxes sweeping sparks from their tails. For thousands of years we thought the lights were omens. Only recently did we realize their signatures, magnetism made visible, proof that our iron heart still beats. But even that protective field isn't permanent. Over the last 2 centuries it's weakened measurably. Satellites passing through the South Atlantic anomaly, where the field is weakest, often flicker, glitch, or even fail. Some scientists worry this might be the first whisper of an impending reversal. Others say it's just a hiccup in a long erratic pattern. Geophysics, it turns out, is full of polite disagreements. If a full reversal did happen within your species' lifetime, the sky would transform, compasses would lose their minds, the auroras might bloom at the equator, painting tropical nights in colour, radiation levels would spike slightly but not catastrophically, humanity would adapt as it always does. You might even get used to the sight of green curtains glowing over desert dunes or coral reefs. A mainstream historical note. When the concept of magnetic pole wander was first accepted in the 19th century, it quietly revolutionized archaeology. By measuring the remnant magnetism in baked pottery or lava, scientists could date ancient structures and flows. A fired clay shard became a miniature compass pointing to the pole's long-forgotten position. Whole timelines of civilization and eruption were rebuilt from magnetic whispers. You look back to your little compass. The needle still trembles, caught between the planet's shifting moods. It's a simple device, yet it connects your hand to the deep engine of the world. Every twitch in that needle mirrors the motion of liquid iron thousands of kilometers below. A direct line from your fingertips to the molten core. You pocket it again and breathe out slowly. Somewhere beneath the crust, the supercontinent seeds are forming, mantle plumes are rising, and the iron storm at Earth's center keeps turning. Above, the aurora flows, magnetic north drifts, and the planet hums through every wavelength of time at once. It strikes you that nothing here ever stays where it's supposed to. Continents move, mountains crumble, oceans trade places, even the poles wander like curious children. The only thing that doesn't move is motion itself. You tilt your head to the sky one more time. A faint arc of green light stretches over the horizon, shimmering like the Earth's slow exhale. Somewhere, the core stirs in response. The field flexes. The compass needles tremble in 1,000 pockets, and for a fleeting second, you can almost feel it. The pull of the poles brushing against your bones, reminding you that no matter how lost you feel, you're always, somehow, aligned with the planet's endless drift. You stay under that green shimmer for a while, the sky breathing in waves, the planet's magnetic sigh fading into the wind. Then you begin to notice what's stirring beneath that same field. Not just rock and fire, but life itself. Every shift in the crust, every drift of a continent, every rise of a mountain has written its influence into the DNA of the living. Life follows the faults. It always has. You step through a valley carved long ago by the collision of 2 plates. The ground here is cracked, fertile, laced with mineral-rich soil fed by volcanic ash. Ferns brush your arms, insects hum in the twilight. The air smells of damp rock and something older. Carbon, sulfur, the faint metallic tang of creation. It's no coincidence that some of Earth's most diverse ecosystems perch along fault zones. When the crust moves, it creates variation. Mountains, basins, coastlines, islands, new habitats and new experiments for life to attempt. If the continents were fixed, evolution would stagnate. Instead, the restless Earth keeps remixing the conditions of existence. Species migrate as land bridges appear and vanish. Oceans close, isolating creatures into laboratories of change. When Pangaea broke apart, reptiles trapped on drifting fragments became dinosaurs of every shape and purpose. Later, when continents reunited, mammals crossed paths that had been separated for millions of years. Each collision sparked new waves of competition and creativity. Historians still argue whether mass extinctions are tragedies or necessities in this tectonic story. 5 major ones mark the fossil record, each coinciding with global upheaval. Volcanic outbursts, continental rearrangements, or climate swings caused by moving plates. After each collapse, life came roaring back, stranger and stronger. It's as though the planet periodically hits a cosmic reset button to keep the game interesting. A mainstream example, when South America drifted into North America about 3 million years ago, it created the Isthmus of Panama. That narrow strip of land changed everything. Ocean currents rerouted, the climate shifted, and animals poured across the new bridge. Armadillos and opossums headed north, bears and cats marched south. The Great American Interchange, they call it. A tectonic handshake that rewrote the continent's biology. And a quirky tidbit to tuck into your mind before you drift off. Deep-sea hydrothermal vents, the same kind that form along mid-ocean ridges, host bacteria that can live entirely without sunlight. They feed on chemical energy from Earth's interior, proving that life doesn't need the sky at all. Some scientists suspect life began there, in those dark fractures where the planet leaks its heat. If that's true, tectonics didn't just shape life, it invented it. You climb a ridge overlooking the valley. Beneath you, steam curls from a line of hot springs, each pool tinted turquoise or emerald by microbes that thrive in boiling water. The boundary between geophysics and biology blurs here. The microbes don't just endure heat, they depend on it. They're living reminders that destruction and creation share the same temperature. Everywhere you look, you see life's responses to tectonic mood swings. Coral reefs grow where volcanic islands cool enough to host shallow seas. Rainforests bloom on nutrient-rich soils born of ash. Even deserts owe their existence to shifting mountains that block rain. The planet rearranges itself, and life edits its script accordingly. You think of the Great Rift Valley in East Africa, the crack that's slowly splitting the continent in two. It's also the cradle of humankind. The tectonic rifting there created lakes, rivers, and isolated ecosystems that encouraged our ancestors to adapt. Different groups evolved in neighbouring valleys, experimenting with walking, thinking, and tool-making. You could say the first spark of human curiosity rose from the shifting crust beneath bare feet. It's almost tender, the way the Earth seems to nurture life through its restlessness. Mountains rise, climates change, and species stumble forward into new forms. Evolution is just biology's version of tectonics, slow-motion change driven by invisible pressure. A gust of wind carries the scent of sulphur and rain. You glance at a nearby fault scarp, a cliff face cleanly sliced by centuries of slow movement. On its ledges, plants cling where they can. You spot a gecko darting into a crack perfectly at home in the chaos. Down in the valley, herons stalk fish in pools created by an old quake that diverted the river long ago. Every tremor leaves opportunity in its wake, and yet the same motion that gives life can take it away. Volcanoes seed fertile ground but also smother it. Earthquakes raise coastlines but drown others. It's all the same process, the Earth sculpting, adjusting, refusing to stay still. Life has learned not to resist but to adapt, to dance with the faults instead of hiding from them. You smile at the thought. Maybe that's the real secret of survival, not endurance but flexibility. Everything alive today is the descendant of something that learned to move with the planet rather than against it. You kneel and touch the soil. It's warm, humming faintly with geothermal energy. Somewhere below, magma seeps through cracks, pushing nutrients upward. The trees around you are taller than they have any right to be, their roots tapping into a chemical symphony orchestrated by deep earth processes. You whisper a quiet thanks to the faults, the volcanoes, the restless crust, for giving the world such astonishing variety. Above you, a line of clouds gathers, thin and luminous in the moonlight. You can't tell whether they're forming from ocean vapor or the breath of a faraway volcano. Either way, they drift with the same rhythm that shapes everything else here. The crust moves, life follows, clouds echo the pattern overhead. For a moment you feel perfectly aligned with it all. The heartbeat of the mantle, the drift of the continents, the slow evolution of life. You're not separate from the planet's machinery. You're part of its ongoing experiment, a temporary expression of its restless creativity. And as the wind rises and carries a faint tremor through the ground, you think, maybe Earth isn't just a planet where life happens. Maybe Earth is life, just stretched across scales of time too vast for most creatures to comprehend. You tilt your head back and watch those thin clouds drift until they blur into the darkness, and for the first time you begin to notice how what happens below, the heat, the quakes, the the slow turning of rock, reaches all the way up into the sky. Every exhale of a volcano, every scrape of a subducting plate sends whispers into the atmosphere. The sky reacts below. When a volcano breathes, it doesn't just paint sunsets, it releases a brew of gases that tweak the planet's thermostat. Water vapor, carbon dioxide, sulfur dioxide. They rise into the stratosphere and tangle with sunlight. Some trap heat, some reflect it. Together they make the climate pulse. You can almost see it, the invisible thread running from magma chamber to cloud top. The Great Eruption of Tambora in 1815 cooled the globe by nearly a degree. 1 year later, the year without a summer arrived. Crops failed, lakes froze in June, and hungry poets dreamed up end-of-the-world tales by candlelight. Historians still argue whether that cold snap helped launch the Romantic movement, or just ruined everyone's vacation. Either way, it proved the sky listens when the crust clears its throat. You walk across an ash plain, the ground soft and grey underfoot. Each step kicks up dust that glitters faintly in moonlight. A gentle wind carries it upward. Future aerosols, future mirrors for the sun. Climate, you realise, is geology in slow translation. The crust writes the drafts the atmosphere edits. Here's your quirky midnight morsel. After the 1991 eruption of Mount Pinatubo, global temperatures dropped about half a degree for nearly 2 years. Scientists measured the effect so precisely that some later proposed mimicking it on purpose, injecting sulfur into the stratosphere to offset warming. The plan sounded almost reasonable, until someone pointed out that permanent haze and acid rain are not exactly spa treatments for the planet. Still, the impulse makes sense. We're children of a world that regulates itself by fire. Every few centuries, the Earth performs a small climatic correction: eruption, cooling, recovery. Those cycles, multiplied over eons, keep the biosphere from spinning too far toward ice or inferno. The trick is balance, and the crust and sky have practiced for billions of years. You stop beside a fumarole, a vent hissing like a giant kettle. Steam curls upward and disappears into the night, carrying trace gases that will drift across oceans before joining a cloud. Somewhere, that vapor will condense into rain, fall onto soil, feed a river, and one day return to the sea that birthed it. The water cycle is just tectonics with better marketing. A mainstream historical note: scientists studying ice cores in Antarctica found layers rich in volcanic sulfur dating back hundreds of thousands of years. Each layer marks an eruption, a climate dip, a brief global shiver. Stack them together, and you get a heartbeat pattern of cooling and warming tied to Earth's inner restlessness. The planet keeps impeccable records, it just prefers to write them in ice. You glance toward a distant mountain range. Snowcaps glow faintly blue, storing centuries of atmosphere in frozen bubbles. Within those bubbles lie traces of every eruption, every shift in carbon and oxygen, every whisper of temperature change. If you could listen closely enough, you'd hear the story of continents colliding told through isotopes. And it's not only volcanoes. When mountains rise, they draw carbon from the air as rock weathers into clay, locking greenhouse gases into the crust. When continents drift across latitudes, they drag climates with them, turning jungles into deserts and deserts into tundra. The slow dance of plates writes the script for wind and rain. Sometimes the script gets rewritten abruptly. The Deccan Traps in India, flood basalts that erupted for nearly 1 million years, poured so much carbon dioxide into the air that they likely helped end the age of dinosaurs. The earth burped, the sky choked, and evolution turned the page. You tilt your face to the wind. It smells faintly of sulfur and salt, as if the ocean and the volcano are sharing secrets overhead. Clouds gather thicker now, swirling in subtle spirals that mirror convection cells in the mantle. Patterns repeat from core to sky, heat rising, cooling, sinking again. You start to see the planet not as separate layers, but as one looping system. A flash of lightning splits the distance. For a heartbeat, you see rain spilling over the mountains like molten silver. Each drop carries a whisper of elements forged below. Calcium from ancient shells, potassium from ash, iron dust from the desert. Even the storm is partly stone. You smile at the thought that every breath you take contains recycled geology. The carbon in your lungs might have once been trapped in limestone, freed by an eruption, drifted for centuries as part of the air, then found its way into you. You're breathing the Earth's exhale. Historians of climate still debate how many times the planet nearly lost control. Snowball Earth, the Paleocene-Eocene thermal maximum, the Ice Ages. Yet each crisis resolved itself through tectonic feedback. Mountains rose, volcanoes vented, oceans absorbed. It's messy, but it works. The Earth is its own thermostat technician. You walk until the fumaroles fade behind you and the stars reappear. The wind has a different sound now, a soft, deep hum that seems to echo both from the sky and from the ground. It's the resonance of two halves of one system, crust and cloud, speaking the same language of circulation. Somewhere beneath your feet, magma is moving again. Somewhere above, cirrus trails mark the flow of jet streams shaped by those very same mountains that magma built. The cycle closes neatly, endlessly. You breathe in, the planet breathes out, and for a moment, you can't tell whose breath belongs to whom. You stand still as that wind fades, the hush stretching wide enough to hold a thought you've been avoiding. People live here. People build glass towers and highways and coffee shops on this same flexing crust, pretending it's steady. The human fault line, the places where civilization and geology share an address, is everywhere. You walk through a sleeping city now, streets slick with rain. Beneath the asphalt runs a hidden web of stress fractures, each one mapped and measured by geologists who wish politicians would read their reports. Street lamps hum softly, oblivious. Someone in an apartment above you turns over in bed. It feels absurdly calm considering that the ground beneath this city moves a few millimeters every year. Tokyo, San Francisco, Mexico City, Istanbul, all perched along zones where plates grind together like stubborn tectonic gears. Each place hums with tension disguised as normal life. A train rumbles past, its vibration briefly indistinguishable from the planet's own. You realize how well humanity has learned to sleep through danger. A mainstream historical note: after the 1906 San Francisco earthquake, the city burned for days. Over 80% of it was destroyed, yet within a year, the people rebuilt, not elsewhere, but right on top of the same fault. Insurance companies rewrote policies, engineers invented new standards, and within decades the skyline rose again. Humanity's memory for disaster lasts about as long as its mortgage cycle. You duck into an alley where warm air seeps up through vents, geothermal heat, shallow veins of the mantle breathing under concrete. The smell is faintly metallic, familiar now. Somewhere below, the San Andreas creeps quietly, moving a few centimeters a year. In geological terms, that's graceful patience. In human terms, it's the ticking of a clock. Historians still argue whether our modern fascination with stability is just denial. Cities cling to fault lines because that's where the resources are. Fertile volcanic soils, mountain water, coastal trade routes. We build where the planet promises abundance and accept the occasional reminder that abundance has a pulse. A quirky tidbit: Los Angeles has an official shake table, a massive platform used to test building designs. Engineers strap entire structures to it and simulate quakes. Some of the tests are live-streamed, complete with commentary. It's perhaps the only place on Earth where people cheer for a building to survive artificial destruction. You step out of the alley and onto a bridge. Below, a river winds through the city, its banks armoured with concrete. But you can still see the original valley, the scar of an ancient fault. Bridges always make you think of tectonics, spans of steel over restless gaps. Humanity's answer to shifting ground is to pretend it's temporary, to keep crossing as if motion were illusion. Street signs point toward neighbourhoods that sit directly on fault traces. People buy homes there, plant gardens, hang art on the walls. Somewhere a dog barks. The ordinary hum of life overlays the deeper hum of the crust. The two rhythms blend so perfectly you can almost mistake one for the other. You pass a small park where a plaque explains that the ridge beneath your feet lifted during an earthquake centuries ago. Children play soccer there in daylight. Tonight it's quiet, just the whisper of leaves. You crouch and touch the ground, packed soil over sediment that once liquefied during a quake. The earth hardened again, but the memory remains, folded in layers of clay. Every city carries these buried memories. Mexico City was built on a drained lake basin that amplifies seismic waves. Christchurch sits atop hidden faults that woke up in 2011. Naples rests beside Vesuvius, patient as ever. People stay anyway, not because they forget, but because living elsewhere feels less alive. danger and vitality share an address more often than not. You glance up at the skyline, steel, glass and concrete gleaming under the moon. Each skyscraper sways slightly, designed to move with the Earth, not against it. Engineers have learned to borrow tricks from trees and bridges, letting buildings flex rather than break. Humanity has, at last, begun to take tectonic advice. Adapt, don't resist. A small tremor passes beneath you. Nothing major, just a gentle nudge. The bridge hums for a second. A few pigeons take off, startled. Then silence again. You realize that somewhere, right now, another small quake is happening on the other side of the world. Hundreds every hour, thousands every day. The Earth twitches constantly, and yet most of us never feel a thing. You walk on, past shuttered storefronts and quiet intersections, until you reach an overlook. The city sprawls below, light shimmering like a constellation of fireflies. You imagine what it looks like from space, tiny veins of brightness tracing fault lines, glowing proof that humanity and geology share the same nerves. Maybe this coexistence isn't defiance, but partnership. Humans have built their civilizations along the planet's fault scars the way moss grows along fractures in stone. Both find footholds where the world splits open. The cracks let in light, heat, minerals, possibility. A breeze rises, carrying the faint scent of ozone and rain. The clouds overhead shimmer with reflected city light, a pink glow that feels strangely biological, like the heartbeat of a living organism. Beneath that soft pulse, the crust murmurs. You think of the next quake, inevitable, unpredictable, already brewing somewhere below. When it comes, people will stumble, rebuild, continue. That's the unspoken pact between species and planet. We keep going, and so does it. Neither side ever truly wins or loses. You rest your hand on the railing, the metal cool and trembling faintly with passing cars. The city hums, the fault hums louder. Both are just different frequencies of the same song. And for a fleeting second you understand that human history and geologic history aren't separate timelines. They're the same story, written at different speeds. You linger on that overlook until dawn begins to tint the city silver, and then your perspective shifts again, from ground level to the sky above, from trembling bridges to silent satellites. The human world has learned to watch the Earth move from orbit, and now, for the first time, the planet's restlessness can be measured, pixel by pixel. Science in motion. You imagine yourself drifting with those satellites far above the haze, where continents below look deceptively still. But the instruments know better. They can feel the pull of millimeters, the subtle creep of Africa inching north, of South America sliding west, of Antarctica slowly pivoting under its frozen weight. GPS isn't just for navigation anymore. It's the Earth's pulse monitor. Every second, thousands of signals bounce between ground stations and satellites, measuring distances so precisely that a single grain of sand's shift could, in theory, be detected. This is how scientists now watch tectonics breathe. They call it INSAR, Interferometric Synthetic Aperture Radar, a fancy phrase for seeing the ground move without touching it. It's a kind of X-ray vision for continents, capturing the subtle swell of magma before an eruption, the slow sag of land after an earthquake, the steady tug of plates against one another. Historians still argue whether this era marks a new age of geology, the Anthropocene, when human observation finally rivals the planet's own patience. We've mapped the ocean floors, traced the faults, even modelled the inner core's rotation. But there's still a humility in the work. Every new measurement reveals another layer of complexity we hadn't imagined. The more we see, the more the planet seems to wink and say, "You still don't really know me." You remember the early days of this science, before satellites, when geologists hammered stakes into the ground and returned decades later to see how far they'd shifted. It was slow, tedious, and heroic in its own quiet way. Today, computers do the same job in milliseconds. A plate moves an inch, and a satellite whispers the update to a server somewhere. The Earth tweets its own position, a quirky tidbit for your sleepy curiosity. The global positioning system itself has to correct for plate motion, or else maps would slowly warp. In some regions, the coordinates of entire cities drift a few centimeters each year. Without adjustment, your phone might one day insist that your favorite coffee shop has migrated into the sea. The data streaming from space doesn't just measure, it warns. Before a major earthquake, the crust sometimes bulges or sags by fractions of an inch. Satellites can see it. Volcanoes too reveal themselves in subtle ways. A swelling flank, a shifting shadow, a plume of heat invisible to human eyes. The technology gives us time, not much, but sometimes enough. And then there's the sound of the planet itself, recorded by instruments called seismometers. The faint, continuous tremor of the Earth, what scientists poetically call the microseism, is never silent. It's caused by ocean waves colliding and reverberating through the crust. You can listen to it, sped up 1,000,000 times, and it sounds like a deep, soothing purr. Even in calm weather, the Earth hums. The seismometers catch that tune and transmit it to databases around the world, a ceaseless lullaby of motion. You drift lower in your imagination, back through the atmosphere, back to ground level where rows of instruments stand like quiet sentinels. Each GPS antenna, each seismic sensor, each thermal camera, all of them part of a vast nervous system we've built to feel the planet's moods. We've turned Earth into something like a patient under observation, though it's a patient infinitely older and wiser than its doctors. A mainstream historical note, the first global tectonic motion network, GeoNet in Japan, was installed in the 1990s. It now uses over 1,000 permanent GPS stations to monitor the archipelago. When the 2011 Tohoku earthquake struck, those instruments captured the exact motion. Parts of Japan shifted eastward by more than 2 meters. It was the first time in history that a nation's shape changed in real time while satellites watched. You look around and realize that technology hasn't made the planet less mysterious, just more articulate. We can now see the invisible. We can translate the subtlest tremors into data, into music even. Scientists sometimes turn seismic readings into sound to analyze frequency patterns. The result? The planet sings in bass notes too deep for human ears. Somewhere inside you, you recognize the odd comfort of that. The more precisely we measure the Earth, the more alive it feels. Those numbers on screens aren't cold, they're evidence of heartbeat. And yet, for all our senses, surprises still happen. A mountain may collapse without warning. A volcano may erupt with little prelude. The planet doesn't owe us predictability. Our instruments are catching up, but they're still chasing a rhythm that predates atoms, let alone algorithms. Still, this chase has its rewards. Thanks to satellites, we can now see the world as a living, shifting organism, one whose smallest gestures shape the grandest outcomes. The Sahara grows as Africa drifts north. The Himalayas rise because India refuses to slow down. Even the tilt of the Earth wobbles slightly as mass redistributes through these motions. We are measuring evolution on a planetary scale. You glance once more at the horizon. The first sunlight touches the mountains that satellites have been tracking for years, measuring their tiny growth spurts, their subtle subsidence. It's strange and lovely to think that somewhere above a machine just noticed this sunrise too, noting a change in albedo, logging it, adding one more data point to the archive of forever. You breathe out, slow and even. For all its sophistication, science is really just another way of listening. One more set of ears pressed to the Earth's surface, trying to make sense of the endless hum. The satellites may orbit in silence, but they're part of the same lullaby you've been hearing all along. From the edge of dawn, your gaze drifts outward again, beyond the satellites, beyond the quiet hum of data, to the future Earth, the one that's still assembling itself. The continents you know are already planning their next reunion, and the clues are all around you, coded in magnetic lines, drifting plates, and whispered models. The next rearrangement is underway. You can almost see it if you speed up time in your mind. Oceans closing like old books, mountain chains rising where seafloor once spread, familiar coastlines bending into unrecognizable shapes. It's not imagination, it's inevitability. The world map is just a snapshot, and even as you trace it with your finger, it's becoming obsolete. Scientists have a handful of competing blueprints for what comes next. One predicts a major, the Supercontinent of the North, forming as the Americas and Asia close ranks over the Arctic, welding themselves into a single, massive cap. In that world, the equator is mostly ocean, the poles are land, and the Pacific, the largest ocean on Earth today, vanishes entirely. Another theory foresees Pangaea Proxima, where the continents gather near the equator again. The Atlantic stops widening and begins to close, dragging the Americas back toward Africa and Europe. Imagine Rio de Janeiro and Casablanca sharing the same coastline, or New York just a short drive from Madrid, though you'll need a few 100 million years and an excellent GPS signal to test it. Historians still argue whether either of these predictions captures the real future, or whether the planet has something stranger in mind. After all, none of the previous supercontinents matched exactly. The underlying rhythm is steady, but the melody always changes. Maybe Earth, like any artist, refuses to repeat itself. You picture the Atlantic as it is tonight, a widening ocean, mid-ocean ridge glowing faintly under miles of water, magma welling up between the drifting plates. One day that ridge will quiet. Subduction zones will form along its edges, pulling it closed again. The Atlantic will be swallowed, and the continents will meet in a slow, grinding embrace. Mountains taller than the Himalayas will rise where the Azores once floated. The seafloor will crumple like discarded paper, and the familiar will vanish beneath something new. A quirky fact to amuse you before sleep takes over. If all continues as predicted, Australia will be the speed champion of the next rearrangement. It's sprinting north at 7 centimetres a year, faster than your fingernails grow, and will likely crash into Southeast Asia first, crumpling islands and raising new mountains long before Africa finishes its northern trek. The planet loves a good overachiever. What happens to life during these rearrangements? Everything changes, of course. Oceans vanish, and with them, entire ecosystems. New climates bloom, deserts become rainforests, and polar regions thaw into fertile plains. Evolution gets another blank slate. Perhaps descendants of the creatures alive today, slightly different, slightly stranger, will wander across those newborn lands, unaware that they're walking atop the ghosts of older worlds. And as the continents gather again, so too will the forces beneath them. The mantle will churn differently, convection cells merging and reorganizing, driving supervolcanoes that make even our largest eruptions look like sparks. The air will fill with ash, the sky will dim for centuries. Yet out of that turmoil, the Earth will cool again, heal again, and start the slow work of pulling itself apart once more. That's the cycle: collision, reunion, separation, renewal. It's a pattern that's been playing on repeat for 4 billion years. Every mountain range is a verse, every ocean trench a chorus. You find a strange comfort in that. The next rearrangement isn't an apocalypse, it's just the next stanza. A mainstream historical note: early 21st century scientists used supercomputers to simulate these future continental movements in 4D, adding not just space, but heat, pressure, and magnetic influence. Their models ran for months, computing millions of interactions. The result? Even the most advanced projections agreed on one thing: Earth's surface is still only halfway through its tectonic life. The mantle remains hot enough, vigorous enough to keep the crust in motion for billions more years. The dance won't end soon. You close your eyes and picture that distant supercontinent. Its skies are orange with dust from newly raised ranges. Massive rivers snake across its surface, connecting seas on opposite sides. Nighttime brings auroras near the equator, glowing ribbons that twist through volcanic haze. Somewhere on its shores, perhaps descendants of humanity, or whatever comes after, watch the same stars and wonder if their world was always this way. You want to tell them that it wasn't, that continents once had different names and shapes, that their land was once ocean, and their ocean once mountain. But you know they'll figure it out. The rocks will tell them. The magnetic stripes, the fossils, the layers of ash. They'll piece together the story just as we have, marvelling at the planet's patience. Somewhere deep below, the molten heart of the world beats on, unconcerned. It doesn't hurry, it doesn't fear, it only moves, steadily, elegantly, indifferent to the creatures counting its steps. Maybe, millions of years from now, someone will stand on a cliff above that new supercontinent, feel the ground vibrate beneath their feet, and whisper, "The Earth is rearranging itself again," and they'll be right. The same story told once more in new shapes and colours. For now, though, the continents still drift in their slow waltz. Oceans stretch, trenches swallow, mountains breathe. The rearrangement has already begun. You're living in its prelude. The maps in your hands are temporary art. Enjoy them while they last. You sit there for a long moment at the edge of that imagined map, your mind tracing the new shapes the Earth will wear, seams closing, folds forming, oceans exhaling their last salt breath. Then your attention turns inward again, down through the crust. where the planet's slow machinery keeps turning regardless of your wonder. It's all still moving, even now, under the quiet of the night. The story never really stops. The thought makes you exhale, long and slow. The air you breathe out drifts upward, mingling with vapor from the sea, ash from volcanoes, dust from deserts. Ingredients of weather, ingredients of time. Everything connects, and you realize that maybe this rearrangement you've been tracing isn't only geological, it's personal. The Earth moves, and so do you. You stretch out on the ground, feeling the subtle vibration under your back, the steady pulse of heat from below. You can almost convince yourself you hear it, the deep whisper of mantle currents sliding past one another. It sounds like an enormous sigh, an ancient lullaby. You close your eyes and imagine it singing you towards sleep. Mountains crumble quietly in the dark. Somewhere in the Pacific, a ridge pushes up new crust. Somewhere in Africa, a rift widens by a fraction of a millimeter. The entire planet exhales, reshuffles, rests, begins again. It's an orchestra of patience, and you're lying in the middle of it. Historians still argue whether plate tectonics will ever truly end. Some say the planet's heart will cool too much one day, the mantle thickening like old syrup until the plates freeze in place. Others think fresh radioactive decay will keep the heat flowing for eons. Either way, the Earth will keep rearranging long after humanity has faded into one of its thinner layers, a faint band of iron, carbon and plastic woven into the stone. And maybe that's fine. You smile at the thought. Our fossils, our skyscrapers, our satellites, they'll become part of the next supercontinent's bedrock, a glittering stratum of curiosity for whatever future eyes evolve to find it. They'll dig us up the way we dig ammonites and trilobites, wondering what strange creatures once drew borders on drifting plates. A quirky detail to amuse the mind. The Mariana Trench, deepest spot on Earth today, is sinking about 1 millimeter a year as the Pacific Plate dives. It's so deep that if you dropped Mount Everest into it, the summit would still sit more than a mile underwater. Yet one day, even that trench will close, folded and forgotten inside a mountain range yet to exist. The deepest place will become the highest. The Earth loves its inversions. You roll onto your side, the ground cool against your cheek, and think about how everything solid has been liquid, everything permanent temporary. The continents that once seemed so proud and fixed are just foam on a slow tide of stone, and beneath all that motion lies a quiet generosity. Tectonics keeps the surface fresh, the air breathable, the oceans alive. Without the planet's constant rearranging, there would be no you to marvel at it. A mainstream historical note, it took until the late 1960s for scientists to fully accept the theory of plate tectonics. Before that, Earth's restlessness was considered unthinkable. They called it continental drift, and many mocked it as fantasy. Yet now it's the foundation of geology, the story that makes every other story possible. You can't study mountains or fossils or oceans without it. It's the key that unlocks everything. The night deepens. The stars above seem steady, but even they move, tracing their own tectonic drifts across the galaxy. You realize there's no such thing as stillness anywhere in the universe. From the flow of magma to the spin of galaxies, everything is migration. Motion is the default state of being. You breathe out again, slower this time, the last of your thoughts dissolving into the hum of the Earth. You imagine yourself shrinking until you fit between the grains of rock, sliding into the slow current of atoms that make up the crust. Down here, time stretches. Seconds become centuries. The planet's voice fills your ears, soft as a heartbeat. Sleep, it seems to murmur. I'm still working. The wind brushes through the grass, and the sound merges perfectly with that underground whisper. You let it carry you downward, into that half-dream where molten rivers pulse and continents glide by like shadows. You drift past mountains growing taller than clouds, past valleys flooding and emptying again. You see the world not as a place, but as a process, endless, patient, magnificent. In the distance, you can almost glimpse the next supercontinent taking shape, though it flickers like heat on the horizon. The air around it hums with potential, the same hum that cradles you now. It's the sound of change, slow, steady, inevitable. You smile in the dark, feeling that hum vibrate through bone and soil alike. The planet is restless, yes, but it's also kind. Its rearrangements are not endings, only renewals. Each fracture makes room for something new to rise. And as your heartbeat slows to match the deep pulse beneath you, the world seems to tilt just slightly, as if adjusting your blanket before you drift away. The continents shift in their sleep. The oceans murmur their ascent. The next rearrangement waits patiently for its cue, and you, small and warm atop this vast moving world, finally let yourself rest. The sound fades until only your breath remains, steady and soft. The hum of the planet lowers to a gentle purr, heat settling, currents easing, the crust sighing itself to stillness for a moment. Every tremor smooths into calm. Every drifting continent pauses mid-step. The air cools. The stars blur. You feel the weight of gravity cradle you, a slow rocking that has been in motion since the planet was new. The ground beneath you no longer feels solid or moving, just supportive, like the palm of something ancient and kind. If you listen closely, you can almost hear the last vibrations of the mantle turning into lullaby tones, deep and velvety. The same forces that build mountains now tuck you in, pressing a quiet warmth through the soles of your feet. Everything that seemed loud a few moments ago, the rumble of volcanoes, the crash of oceans, the thunder of faults, fades into one continuous hush. The world is exhaling, and you are part of that breath. Let your body match it. Long, slow inhales, easy releases. The continents will keep gliding while you sleep. The Earth will keep spinning. You don't have to hold it together. It's been doing that just fine for 4 billion years. So sink a little deeper into the dark, feel the pulse of the planet slowing under you, and let the thought of shifting plates become the rhythm of your dreams. Tomorrow the world will still be moving, still rearranging itself in quiet perfection. For now, it just asks that you rest with it. Good night, traveller. The Earth is still turning. Sweet dreams.